Okay, so now we're going to see how the conjugate pairs rule works, and we're going to look at these problems backwards. So we were taking polynomials in standard form and factoring them until we had all the zeros and in factored form. Now we're going to start with the zeros. We're going to write factored form, and then we're going to multiply it out to create a polynomial in standard form. So now we're given the zeros and creating the polynomial that could have those zeros. So just kind of a reverse engineering of this problem. All right, so it says write a polynomial in standard form if its degree is 3 and it has zeros of 2 and 3i. So our first step is to write the zeros. So the zeros that we were given are 2 and 3i. Because we know that all complex zeros come in pairs, we know that if we have 3i, we also have the zero of negative 3i. Okay, that comes from the conjugate pairs rule. So they're only going to give us one of those complex zeros, and we have to know the other one. That's part of the problem. All right, now we're going to write this polynomial in factored form. If we have the zeros, it's easy to write a function in factored form. We're always going to do, the factors are always x minus the 0. So this would be x minus 2. This one would be x minus 3i. And this one would be x minus a negative, so x plus 3i. Okay, so this is our factored form of the polynomial. Okay, to create standard form, we're going to FOIL and double FOIL. We're going to multiply it all out. Okay, so to create that standard form, we need to multiply it out. So what I like to do, and I highly recommend this, multiply the two non-real or complex zeros first. It's going to make the whole problem a lot easier. It's not wrong to multiply the x minus 2 times the x minus 3i first, but it's just a lot more work. There's a lot more terms involved, and you're probably, easier to go wrong, to go astray. So just multiply those conjugate pairs first, because what you'll see is some things work out for it. All right, so for these two factors, right, we still have this x minus 2 out front, right? That's this one. But then for this, when we multiply this out, hopefully you know FOIL. It's just a good way to keep making sure you get all the terms. It stands for FOIL, first, so it's x times x, that's x squared. Outer, that's this term and this term, the outermost term. So that's x times 3i, so that is plus 3i times x. 3ix. The inner is the ones that are next to each other, and that is negative 3i times x, so that is minus 3ix. And then L is last, and that is this second term here times this second term here. So that is negative 3i times positive 3i, so I'm looking at minus 9i squared. All right, so let's take a look at this and see some happy little things happening. So x minus 2, we still have x squared. Obviously, positive 3ix and negative 3ix will cancel each other out. So we're left with minus 9i squared. Okay. However, here is the trick. So if I is equal to the square root of negative 1, right? That's the definition. We just defined it that way. Then when we square that, I squared is equal to the square root of negative 1 squared, right? We're just squaring both sides. Okay, so you're squaring the square root, right? And those are inverses, they undo each other, right? So the squaring and the square root undo each other, and you're left with negative 1. So in other words, I squared is equal to -1. All right, so I squared is -1. So right here, we need to use that fact. I squared is equal to -1, right? So that means this is x minus 2 times x squared, and it's minus 9 times -1, so it's plus 9. Okay, if you think back to another problem we've done, we did x squared plus 9, we set it equal to 0. We subtracted the 9, and that's how we got plus and minus 3i, right? And that's where we got those zeros. So this is just working in reverse there. Okay, so far all we've done is multiply out the two complex factors. Now we're just going to finish the problem by multiplying, just foiling out these factors. So just x minus 2 times x squared plus 9. You can still use FOIL, just be real careful to, multiply each term to the other term. So x times x squared is x cubed. X times outer is x times 9, so that's plus 9x. Inner is minus 2x squared, so there. And last is -2 times 9, which is -18. Okay, the way I wrote the terms, they're actually out of order, and if I want standard form, I want to put them in order. So let's just rewrite f of x is equal to x cubed minus 2x squared plus 9x minus 18. And then a final note, this is one possible polynomial. This is not the only polynomial because it does have those zeros, but we don't actually know what the leading coefficient is. We don't know what that a value is because we were not given any other information about like another point on the graph besides the zeros. Okay, so that's what they'll usually say is they'll say find a polynomial that has these zeros.